The universal power of graphs. Once upon a time, in a world interwoven with ancient knowledge and modern discoveries, there existed a remarkable tool known as the graph. This tool was more than just a collection of lines and points. It was a powerful language, universally utilized across various academic disciplines and by people worldwide for a multitude of purposes. In the night sky, the graph mirrored constellations, connecting stars into patterns that told the stories of the cosmos. It was the blueprint of architects and engineers, mapping out grand structures and intricate designs. It held the wisdom of the Akashic records, capturing the essence of all that was, is, and ever will be. The graph was the web that interconnected everything, forming the very fabric of reality. From the dawn of civilization, our ancestors relied on graphs to build the first ancient societies. They used graphs to plan cities, navigate the seas, and understand the mysteries of the natural world. These early civilizations recognized the enduring significance of graphs, embedding them into the core of their knowledge and achievements. As time progressed, the concept of graph theory was rediscovered in modern times, particularly during the 18th and 19th centuries. Mathematicians and scientists formalized this ancient tool into a mathematical discipline, realizing its profound potential. Graph theory represented not just graphical representations, but a symbolic depiction of the cosmos, embodying the universal laws that govern the fabric of reality. On the most basic level, numbers served as the building blocks of graphs. They were abstract symbols or representations used to quantify and measure quantities, values, and concepts. Numbers were fundamental to mathematics, enabling us to count, calculate, and describe numerical relationships. They represented quantities of objects, measurements of space and time, and values of variables in equations. Numbers transcended cultural and linguistic barriers, serving as a universal language for expressing numerical concepts. The common foundation of numerical principles, such as place value and the properties of addition, applied universally across all mathematical systems. While different languages might use different symbols or words to represent numbers, the underlying concepts remained consistent. Numerical concepts were utilized across cultures and societies for various purposes, such as counting, measuring, and problem solving. The principles of arithmetic, geometry, and algebra were universally applicable, enabling diverse communities to engage in mathematical practices. Mathematics, including numerical concepts, was considered a universal language because it was based on logical reasoning and precise definitions. Mathematical concepts and proofs were universally understood by mathematicians, regardless of their native language. This universal understanding allowed people from different linguistic backgrounds to communicate and collaborate in mathematical contexts. In the modern world, graphs continue to play a vital role in various fields, from science and engineering to economics and social sciences. They provided a clear, visual way to understand complex data and relationships, revealing patterns and trends that might otherwise remain hidden. Graphs enabled informed decision-making, problem-solving, and meaningful connections across disciplines. In classrooms, teachers used graphs to educate students about mathematical concepts, helping them appreciate the importance and universality of graphs. Children learned to create and interpret graphs, developing skills that would serve them throughout their lives. Across cultures and languages, graphs facilitated communication and collaboration, breaking down barriers and fostering a sense of global connection. Mathematicians and scientists from diverse backgrounds worked together, using graphs to explore and understand the world around them. Graphs were not just tools for data representation, they were a universal connection, a way to understand and interact with the world. By appreciating the importance and universality of graphs, humanity could harness their power to create a better future. And so, the story of the graph continued, a timeless tale of connectivity, understanding, and the unending quest for knowledge.
Graph plot the course to a new port. Astronomical fades on the gray marble floor.